We tend to think of our universe as everything we can see. All the stars, the planets, the galaxies. But what if all of that is just a copy, an echo of an invisible universe that was here first? Okay, let's get into one of the wildest new ideas in cosmology today, the dark plasma hypothesis. This quote right here, this really gets to the heart of it. The idea isn't just that dark matter is floating around out there. It's that dark matter might be providing the actual blueprint for the entire structure of our cosmos. It's a total game changer in how we think about everything. So, to really wrap our heads around this new idea, we first have to start with what we already know, or at least what we thought we knew about dark matter. For decades, the standard picture of dark matter has been, well, kind of boring. We've pictured it as this quiet, passive scaffolding. Its only real job is to provide gravity, like the steel frame of a building that everything else gets attached to. But what if that frame isn't just sitting there? What if it's dynamic and has a complex, hidden life of its own? And this is where the story gets really, really good. Because when astronomers point their telescopes out into the universe, they're seeing things strange, puzzling shapes that just don't fit with that simple, passive model of dark matter. So let's put on our cosmic detective hats for a minute. We've got a few key pieces of evidence, clues that are scattered all across the universe that are all pointing to the same conclusion. There's something more going on with dark matter than just gravity. All right, clue number one. These beautiful, almost impossibly perfect shells of stars. Now, the old explanation was maybe they're ripples from galaxies merging, like a stone tossed in a pond. But when you see 20 of them, so neat and orderly, it's almost too organized. It really hints that something invisible is arranging these stars into this perfect pattern. And here's our next clue. When these huge galaxy clusters smash into each other, we expect the dark matter to just ghost right through itself. But nope, that's not what we're seeing. Instead, it seems to be forming shock waves, what we call bow shocks and Mach cones. Like the V-shaped wake you see behind a boat. That's classic plasma behavior, not something you'd expect from a simple gas. And finally, clue number three, the big one, the cosmic web. This isn't just a theory anymore. We've actually seen its shadow. We're talking about a vast, spongy network of dark matter filaments stretching across millions of light years. And galaxies? They just form at the intersections, like little dewdrops on a giant invisible spider's web. It's the biggest thing in the universe, and it's made of dark matter. So, okay, we've got the shells, we've got the shocks, and we've got this massive web. None of them really fit the old story of passive dark matter, and this has led some physicists to propose a seriously radical new solution. I want you to meet dark plasma. The whole idea is that at least some of the dark matter out there isn't simple at all. It's a complex, self-interacting thing. The particles can actually push and pull on each other through a brand new hypothetical force, a kind of dark electromagnetism. And that lets them act together, collectively, just like the plasma we're familiar with. Now, this is a really important point. We are not talking about normal plasma that's just too faint for us to see. We've looked for that, and the data from the early universe pretty much rules it out. No, this is a completely different beast. It's made of dark matter particles interacting through a dark force. And that's why it stays completely invisible to all our telescopes. The only way we know it's there is its gravity. So, how does this one radical idea, dark plasma, suddenly explain all three of our cosmic mysteries? Well, this is the aha moment, where all the clues suddenly start to click into place. The way it works is actually brilliantly simple. First, the dark plasma, because it has its own internal forces, naturally organizes itself into these complex shapes. You get concentric shells, you get shock fronts, you get massive rotating filaments. Then these huge dark structures create a powerful gravitational blueprint. And finally, all the ordinary matter, the stars and gas we can see, just gets pulled by gravity into this pre-existing pattern, basically tracing its shape. So you see, the core idea here is that those puzzling cosmic shapes aren't random at all. They are echoes. Those strange shells around galaxies, they're just the visible matter that's fallen into invisible shells of dark plasma. Those shock waves from colliding clusters, that's exactly what you'd expect from crashing clouds of dark plasma. And the cosmic web? Well, that's the actual skeleton of the dark universe itself. If this hypothesis is actually right, the implications are, well, they're profound. This doesn't just change how we see dark matter, it changes how we see, well,
everything. And this is where the sheer scale of this idea really hits you. If this model is correct, then active, self-interacting plasma, both the dark kind and our ordinary kind, makes up a huge chunk of the universe. But the vast majority of matter might be a kind of dormant dark plasma, giving us the passive gravity we always thought was there. It suggests that almost everything in the universe is some form of plasma.
Let that sink in for a second. The big takeaway here is absolutely mind-blowing. We don't just live in a universe that has plasma in it. We might be living in a universe that is, fundamentally, a plasma universe. It's a pretty wild thought, isn't it? We've always thought of our visible universe as the main show. But this theory suggests we might just be living in the shadow of a much larger, much more dynamic, and completely invisible reality. It really makes you wonder, if this ghost universe is real, what other secrets is it still keeping from us?